Let's start. So it's part of ML in depth day 14, or whatever we are doing. In fact, till now is all part of a data analytics in depth day 14. Right? You can call it whatever you want. So as a part one of this, what we are studying, what we'll be studying just now in today's session, that is Pandas. So that's the most important thing that you will be needing in be it a data analytics, be it if you're doing a data analytics, you still need it. If you're doing any time series analysis or whatever analysis, you still need it. If you're doing a machine learning, you still need it. Deep learning, to some extent, you again still need it. Right? So mainly for a data analytics and for machine learning, Pandas is the most important library that you will be needing, right? And that's why when we cover it, it will go at least for 12 hours, or at least for 8 to 12 hours. It depends on how well or how quickly you give the answer for. Again, Pandas, it has got nothing to do with the name Pandas animal, right? It has got nothing to do with the animal name Pandas. It stands for Panel Data Analytics, right? Maybe they took panel, PAN, D from here, maybe A from here, S from here, and gave it a name Pandas. That is obviously simple to remember. So it stands for Panel Data Analytics or Analysis, right? Analytics or analysis, all of it. So this is a full form of Pandas. Again, what do you mean by panel data analytics? Is it simply means that when you're working on a data, most of the data that you have in a SQL tables or in an Excel format is having this kind of a structure. So this is my column names. Column 1, column 2, column 3, 4, and 5. These are my columns. And these are my rows. Row 1, 2, 3, 4, 5, 6, and so on. So when you want to work on this kind of a data structure, that's for that you use a panel data analytics. So if you are going to look into any of the data sources, right, that you commonly use, be it an Excel or a CSV file, comma separated value files on an Excel, both are similar, be it a SQL table or any other relational database, be it an Oracle, SAP, DB2, or whatever. All these kind of a data is stored in this particular format. All this kind of a data is stored in this particular format. These kind of a data is not stored in an arrays or something like that. Everything is something like this, a table or simply an Excel sheet, right? Everything is stored in a format of an Excel sheet. We're not talking about a NoSQL database. We are only talking about relational database, which is the most common database and which actually has lot of data in an industry. So if you are working on an Excel, you are working on a SQL, you needed some data structures that is like this, that looks like an Excel sheet, right? And this kind of a data structure is provided by Pandas, right? And the name of that data structure is called as a data frame. The name of this data structure is called as a data frame. By any chance, if you have also studied a big data and you have studied Spark in big data, by any chance, if you have studied Spark also had something similar called as a data frame only. And this data frame and the Spark data frame is also very much similar, right? Only difference in case of a Spark data frame is this kind of a data frame, the entire data will be stored in a single machine. It will be in a single machine, in a single computer, in a single server. But in case of a Spark, the same data frame, that is a distributed computing. So some part of our data will be stored in a different computer, some part of our data in a different computer, some part of data in different computer, and some part in a different computer, right? Or a different servers. So what is eventually a data frame? Eventually a data frame is nothing but an Excel sheet. You can think of it as an Excel sheet. Now, what is the difference between a Pandas data frame and a Spark data frame? Pandas data frame, that sheet will be in a single computer, in a single computer RAM. But in case of Spark, the data frame will be broken into small parts and it will be present in different computers. That's called as a distributed computing, right? So not to diverge much, but just remember what is a data frame. Data frame is something similar to an Excel sheet, which closely relates to any of the data source that we have, like Excel, CSV, SQL, Oracle, and so on, so that we can easily do data analytics, or we can easily do machine learning. So Pandas is a very key thing that enables a machine learning for us. Okay. So what are the different kind of a data that we can work on in case of Pandas? We can work on heterogeneous data, and homogeneous data. So when I say this word heterogeneous and homogeneous data, what does it mean? So if a Excel sheet is given to you, let's say Excel sheet is given to you, and these are my all columns. These are all my rows of data, and these are my different cells available, right? This is how an Excel sheet looks like. This is how a table also looks like. So when I say homogeneous data, let's say this column name was roll number, name, age, and nodes, right? So if I say homogeneous data, age is only having numbers and so on, right? So this is called as a homogeneous data, a single data type. A name can also be regarded as XYZ, ABC, again a single data type. Roll number also may be a single data type. But when you talk about a nodes, someone can write ABC in a nodes, someone can write just a number in a nodes, someone can write a star in a nodes, someone can leave the nodes as blank, NaN, or a null value, someone can leave it as a blank. So there is a lot of variety of a data that is coming over here, right? So it was alphanumeric ABC, this was a numeric one, this was some special symbol, this is a null value. So this kind of a data is called as a heterogeneous data. If you are having a lot of variety of a data in a single column, right? Homogeneous, over here, everything was a number, everything was a text, everything was a number. So it's a homogeneous. Heterogeneous, meaning there is a huge variety of a data. So using Pandas, you can work on both homogeneous data as well as heterogeneous kind of a data. It has a good indexing capabilities. So when you say a good indexing capabilities, it simply means that are you able to refer each and every cell of this and each and every column of this and each and every row of this or not, right? So if I want to refer to this particular row, I should be able to access it. If I want to access to this particular column, I should be able to access it. If I want to access to this particular cell, I should be able to access it directly, right? I should just say that I want a row number 5 and a column number 8, and I should be able to get it, right? So good indexing capability simply means in case of a pandas is that you are able to refer to a particular row or a particular column or maybe a particular cell as well in case of this. So it has a good indexing capability. It has a good time series functionality. So what do you mean by a time series functionality is you're able to store a time series data. What do you mean by a time series data? Time series data meaning your x-axis will be time and your y-axis will be some value. Example will be a stock market, a price of a share of some particular company, let's say Reliance. So what is the share value of a Reliance? How is it going, right? Something like this. So this is a time series data. Along with the time, it is increasing, and for in each time value, there is some value of a stock price. It is either increasing or decreasing. This is an example of a time series data. Any other example of a time series data?
Apple phone price.
Sorry,
Example, Apple phone price.
Apple phone price. Yeah, phone price. Okay, what else? Anything from your
You can say
industry?
sales, credit card
Sales,
sales.
sales. Okay, credit card sales. What else? In case of insurance, what is the increase in premium? Premium collection every month?
Premium versus the age, basically. Yeah,
Oh,
I
no,
mean,
not versus the age. It will be always a time on one axis. So every month, how much was the premium collection? So one axis has to be time. So Pandas basically also supports the time series well, and programming is simple. Programming is simple. You are easily able to manipulate data manipulation, and cleaning is, you can do data manipulation and cleaning. What do I mean by cleaning? This, let's say this NaN. NaN stands for not a number, not a number, right? Or it is just same as null. Okay, it's just a name as not a number, but it is actually means that you're talking about null values. So you want to clean this null value. If you have a null value, how are you going to do the data analytics, right? Again, cleaning. You don't need this special character star. You need to do some data manipulation. Let's say the name was XYZ. You want to make everything to a lower character. Something is capital, something is a lower. You want to make everything to lower characters. So that's a data manipulation. So all these things can be done very easily using Pandas. And more fancy name of this is data wrangling and data munging. Okay. So this is the more fancy name. If you come across a job profile where they are looking for data wrangler, data munging, it effectively means that data manipulation and data cleaning, and it effectively means that you should know Pandas. Okay, so data wrangling, data munging, so these are all fancy names. So just remember what is data wrangling, data munging. It means that data manipulation and data cleaning, nothing else. Again, when you are working with the data, you will need to do some joins. You will need to do group by. You will need to do all these things, right? It can be done in Pandas as well. So joins, group by. What is joins and group by? If you have learned SQL or you know any relational database, you know what is joins and group by. If you don't know, just leave it for now. If you're new to programming, just leave it for now. What is joins and group by? We are going to see anyhow when we do practicals. Any questions till now, anyone? If no question, then let's go ahead. So basically, what is this Pandas offering? We understood that it is offering some Excel-like structure or data frame. So what else it is offering? So basically, it offers two data structures to us. The first kind of a structure is called as a series. And the second kind of a structure is called as a data frame. Second kind of a structure is called as a data frame. So series is very much similar to one-dimensional array in NumPy, right? It is very similar to a one-dimensional array in NumPy. That is, you will be having a number 1, 2, 3, 4, whatever, 5, 8, 10, right? This is your one-dimensional array that is present in a NumPy. So it's similar to a one-dimensional array that is present in NumPy, that is a series. And data frame is something like this, as we discussed before. You're going to have certain rows and columns. So you're going to have a column 1, column 2, column 3, and so on, right? And you're going to have a row 1, row 2, row 3, row 4, row 5. Looks like this, right? So you are going to have a rows and columns. So this is my data frame. This is my series. Now let's, this is very simple terms. Now you need to remember few other things, right? The only difference between a NumPy array and a series in a data structures of a pandas, okay, what we studied for one-dimensional array in NumPy. So we said it is a similar to one-dimensional array in NumPy. But there is some difference, right? What is the difference? Over here, you will also have an index. You will also have an index to it. You will also have an index to it, right? And you can change the value of the index also. I've given the index value as 0, 1, 2, 3, 4. I can change the value of index. I can say that instead of 0, I can say this index is A. This index is B. I can also have a repeated index. B can be 2 times C, D, right? But if I don't specify the index, it is going to take the index as 0, 1, 2, 3, 4, 5. If you specify the index, you can also specify the duplicate index, right? So the difference between an NumPy array and a series is you can also have an index, and index can be also a duplicated index, like this index and this index is same, P and B, right? So this is the only difference between an NumPy array and a series, wherein a series you can also define an index. So what is this called as index? What is this called as index? Okay. Similarly, in case of a data frames, the row number that I have given to you, 1, 2, 3, 4, 5, its default value will be 0, 1, 2, 3, 4. Okay, the default value is 0, 1, 2, 3, 4. Again, this is also called as an index. This is also called as an index. This is also called as an index. Okay, this you can still call it as a columns. This is called as a columns only. This is called as a columns. So the default values will be 0, 1, 2, 3, 4. And this is also called as a columns. When I say index, I mean either you can say index, or you can also say rows, or you can also say columns over here. Another way to denote is you can call it as a axis 0. This is axis 0. And another way to call this is also called as a axis 1. Okay. So either you can call it as a axis 0, and you can call columns as axis 1. So these are the few important things that you need to remember. If you remember these things, it will be very easy for you to later on follow the things, right? So this is the thing where I want to give more emphasis.
So the one question, Harish, is so when we saying array is like the list or like whatever we discussed, right? Previous lecture, previous session. So it's the same thing, right?
It's just the same thing, just that you can have it's kind of a mixture of arrays and dictionary.
Yeah, correct. Mixture of array and dictionary.
But again, not exactly dictionary, because you cannot have a duplicate keys in a dictionary. Here you can have a duplicate indexes.
Okay. So meaning, NumPy, we have the array also with duplicate indexes, basically.
No, NumPy
possible.
you don't have a duplicate, right? NumPy you have a 0, 1, 2, 3, 4.
Okay, sorry.
You are not having that. In Pandas series you have. Yeah.
Yeah, sorry, I mean Pandas. Okay. Okay, thank you.
Okay. So a few of the things, let's revise. What are the two data structures that Pandas offer? Be quick, be quick. We
Series,
want to cover this in 8 hours instead of 12 hours.
series and data frames, right?
Series and data frame, right? So if we complete today and tomorrow, it will be more in sync with you. If we drag it to next week, then I will have to take 1 day leave also because cannot start a new topic. So let's try to complete this today and tomorrow. Series and data frame, these are two data structures. Similar to a series is similar to what in NumPy?
Array.
One-dimensional array. But what is the difference between a one-dimensional array and series in Pandas?
So series can have the index also. Index can be any number.
Yeah, internally there is an index, yes. In case
And
of
it can be
in case
repetitive.
of a NumPy, there was index. In series, you have an index, and you can also have a duplicate index in case of a series. Okay, how about what is a data frame? How do you define a data frame, or what is this axis? What is
I mean
this?
zero.
This is a rows, and you call it
So
as a axis 0. How do you refer it? Index, right?
with index,
This
yeah.
is index. So if I say index, that means I am referring to this side. If I say column, that means I am referring to this side. Similarly, if I say axis 0 meaning I am referring to this particular side. And if I say axis 1, that means I'm referring to this particular side, right? With this, let's go to practical unless you have any doubts, anyone.
No.
So let me share the notebook. Is the I mean the Edge browser visible?
Yeah.
Okay, perfect. So let me clear the output. So I just say run all. It will try to run all, and it will stop here, and you can go to run and say interrupt execution. Right. So all my outputs are cleared, but I still get that black. So this is one of the way workaround to clear all the outputs. And can I also remove this red sign? Maybe I do restart runtime. Will it remove? Yeah, restart runtime. So this is a cool way of clearing the output. I couldn't find anywhere in the notes, anywhere in the net. Okay. So let's start with this sheet. So when you're learning, why is it not giving me this pen? Okay, it took some time. Okay, so when you're learning anything for data analysis, right, or for machine learning or going forward anything, learn in 3 steps. The first step is given the code and output both. Let's say your code is given and the output is given to you. Are you able to understand it? Why that code is generating that particular output, right? What do I mean by this is, let me execute this. So let's say I'm executing this. It's responding little slow. By the time it responds, I click 2 times and it takes me somewhere else. Okay. So what do I mean by that? I'm doing some import and I'm running this 3 lines of code. Okay. So what I mean by that is the step number 1. So 3 steps learning for any of the things. I can take you till step number 1 and step number 2. Step number 3 you have to do. Given code and output, are you able to understand why that output is coming? So this is the code is given to you. Okay, it's the same. This code is given to you. This output is also there in front of you. Are you able to understand why this output is generated? Okay, by looking at in the code as well as output. Given a code and output, are you able to understand? Okay, if you are able to understand, that means you have done a intermediate level or just a basic level. I mean, not intermediate, basic level. You have basic level understanding. At least you will be able to judge the things by looking into a code and the output. Second things, given the code, are you able to predict the output? Okay, predict the output, or are you able to make out what will be the output? Make out what will be output. Okay, so given that, okay, given the code, you only have an access to this code. You don't have an access to output. By looking into the code, can I understand what will be the output that will come over here? Am I able to judge what will be the output? Okay, if you are able to understand that, looking at the code, what will be the output, that means you are able to apply for a job and you are able to go for interviews and you are able to work as well. And the third step is when you start working on this thing for 1 year, 2 years, you should be able to write the code by yourself without any reference. Write code without any reference. Okay, I mean, you don't have to Google what is the syntax. You know all the syntax. You know all syntax. Okay, but this will come with a practice. Maybe at least 1 year of practice doing the same thing day in and day out, right? Even after that, it sometimes doesn't come, but at least you should be able to do 70 to 80%, right? So just remember 3 steps. The first step is given the code and output, you are able to understand why the output is coming. That means you are at the basic level. You have listened to my video properly, at least, or whatever you are studying, you have studied, at least you have understood something. Second thing, given at the code, are you able to judge what will be the output? That means your mind is running in that way. You will be able to work wherever you go. And the third thing is uh, write the code without any reference, without the use of Google or without using a reference code. So just reach to step number 2 as soon as possible and start applying for the job. Okay, let me save this. Okay, so let's start discussing about this Pandas. It's a very popular in data science, can perform operations that cannot be done in Excel on a bigger data set. That cannot be done in Excel. Okay, you will find, if you know Excel, you will find it very similar and very easy to use. How to refer the things, it's also very similar if you have used Excel also, even if you are coming from a business background. It uses a data frame for performing data processing. So you can just think of a data frame as an Excel sheet, nothing more than that. A data frame are like tables, like data structures having rows and columns, right? It is similar to the Excel sheets. So they are a table like data structures having rows and columns, or it is very similar to whatever you have an Excel sheet. Just think of a data frame as an Excel sheet. So we are going to study series first. And once we are done with the series, we'll go to data frame because it will be easier, right? What is a series? Series is also having an index, right? Series you can think of like this. there is only single column, only one column. So you have an index 0, 1, 2, 3, 4. You are having A, B, C, D, whatever. So this is a series. You can think of it as just a single column over there. But if you add multiple columns, then it will become a data frame. So we'll start learning the series first, because series is nothing but just very small. Just you can think of a one column. You can just think of a one column. And once we are done with the series, we'll go to a data frame and it will be easier to pick up. Series are not much used, but we'll still cover it because it makes the understanding a little bit easier later on. So it is very a few things I will ask, and you should answer me very quickly. What is this doing? Import pandas as PD.
Meaning importing all classes
Okay,
in
or
the program,
importing
right?
all the functionalities that are available in
Functionality.
Pandas. And if you want to refer to that particular functionality, you have to refer as PD dot. What is this
Yeah.
doing?
Same for the NumPy. All
Import
the
NumPy.
functionalities available in NumPy.
So it is importing all the functionalities available in NumPy, and you want to use it, you have to use as NP. PD and NP is an industry standard. You can use anything, but you should use only PD and NP because it's a standard. Again, you're creating the first data structure, that is a series. It is similar to NumPy one-dimensional array. It is very similar to a one-dimensional array in series. So series example is nothing but I'm just giving a name to it, and pd.series 10, 20, 30, 40, 50. So I'm assigning this value to 10, 20, 30, 40, 50. At the end, I'm just writing this series example at the below. So when I write this series example at the below, it just basically prints whatever is the value inside it. So it is having pd.series 10, 20, 30, 40, 50. So 0 is 10, 1 is 20, index 1 is 20, 2 index is 30, 3 index is 40, 4 index is 50. Okay. Then what is this 0, 1, 2, 3, 4? What is this 0, 1, 2, 3, 4?
Index. Meaning,
Index.
yeah, index.
Yeah, perfect. And what is this 10, 20, 30, 40?
The value
These are the values. Okay. So
on that
0, 1, 2, 3,
index.
4 is index, 10, 20, 30, 40, 50 is a value. Okay. So yeah, whenever I ask, you can unmute yourself and answer me, but immediately mute yourself. Okay. So print series example dot values. So obviously it is going to print the values as 10, 20, 30, 40, 50, and series example dot index is going to print the index 0, 1, 2, 3, 4. So you can see that if you print values, it is going to print the values 10, 20, 30, 40, 50. That is over here. Index, it is saying that index is starting from 0 and index is stopping at 5, and there is a step of 1. There is a step of 1. This will give only that. Okay. So this is giving you the series. What is the start? What is the stop? And what is the step? Okay. So let's go ahead and see. This is the same series example, whatever data we were having. You are saying that I want the value at third index. So what is there in the third index? What is there in
40.
the index 3? Index 3, what is
40.
that? 40. So it is going to print 40. What is this going to print? 3, 4?
3 and 4 index. Value in the 3 and 4.
40, 50.
40 and 50.
So 40,
Right?
50.
Perfect. So this prints 40. If I say only for 3, if I say 3 and 4, it prints 3 and 4, that is 40 and 50. Anyone has any doubts, just stop there and stop. Ask me, because if this is not clear, nothing is clear. You cannot do data analysis, right? And series example greater than 30. Okay, series example greater than 30. So what is this going to do internally, right? How it is going to work internally? So what this will do is, we are asking series example greater than 30. So is it greater than 30?
No.
No,
So it will give a false. This one,
false,
No.
this one,
False.
false,
It's greater than 30, not greater than equal to, so false. And 40 and 50 will be obviously true and okay. So if I just execute this piece of code, okay, try to understand the code in small piece. If I execute just this piece of code, I will get this thing. Okay, and get this thing. And when I put this piece of code also, so it's giving to give me the entire series. Series example was giving me entire series. Okay, it was giving me entire series. But since this piece of code is also there, this is a false, so it won't be printed. This is a false, it won't be printed. This is a false, it won't be printed. And it is only going to print this 40 and 50, right? So when you're debugging a code, when you're trying to understand what is written into a code, just start looking from inside out. So inside out, right? Even if you do a mathematics, you are doing inside out. First, you are doing what is there in the bracket, 2 into 5 plus 3 into 7, right? So you are doing this thing first, 10 plus 21, right? And then comes 231. You are not doing just 2 into 5, 10 plus 3, 13 into 7. No, not like that. So you are doing first the what is there inside a bracket, right? Similarly in programming as well, make the life simple. What is there inside? Series example greater than 30. So it will give me false, 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 true, true. Series example, what will it give me? It will give me the entire thing. So if I put an entire thing with this thing, false, 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 true, true, it is only going to give me this 40 and 50, right? So understanding and debugging or interpreting the things is very important. So you are getting 40 and 50, right? And if you ever find it difficult, you can always take whatever is there inside a bracket and run it, right? So it was giving me false, 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 true, true, right? If I run this entire thing, it is going to give me everything, right? But when I merge this everything with this false, 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 true, true, it is only going to give me 40 and 50, right? So to explain, I can easily explain you as well. I can just say, oh, this is given, so that means this is this, right? And I can just go ahead. But when it comes to more and more difficult things, it gets more difficult to interpret the things. But if you are interpreting it very simply, what it means, how is it executing internally, then it makes the life little bit easier, right? So always think of executing what will be the output inside. Anyone having any questions in this so far? Anyone having any questions?
Harish,
Yeah.
why it is printing the data type as well for
It's
each?
printing the data type because this particular function is returning this data. So
Okay.
yeah, it prints because it is returning this data as well.
Okay. Okay. Understand. Thanks.
Okay. So series EG star star 2. So what will this do? Series EG star stars 2. What was the value meaning of double star?
Multiply?
Multiply
No,
single
no.
star.
The root, square root.
Square
to
root
power
or
square.
square? Square. Square root is a function SQRT. Square. Star star is a square. So this
Yeah,
series
square.
example square star star is 10 10. What will be the value? If I take a square of each and every element,
So
what will
100,
10 become?
100,
10 will become 100, 20 will become
400,
30 will become
900,
40 will become
1600,
50.
2500.
Okay, 50 into 50, 2500. 5 into 5, 25 and double zero, 25. So it is just taking a square out of it. Each and every value 10, 20, 30, 40, 50 is just taking a square out of it. Okay, good. So this was my series. Let me print my series again. So that this was value inside my series. Okay, series dot series example. So what this is going to do is it is going to check this particular value 2. This value 2 is present in the index or not. Can you see this 2 anywhere?
Yeah.
So what will it return? Will it return true or false?
True or
True.
false? Yeah.
So it will
So
return
true.
true, right?
Yeah.
Yes.
So 2 is present in series example. So it is going to look into the index whether you are able to find this 2. Since you are able to find this 2, it is giving a series example. It's giving a true. Okay. What is this doing? Can anyone tell me?
Is it in like value? 2 is there in the row. I mean in any of this series basically. Series
Again, I
value.
have given an index, right? Series example dot index. So series example dot index meaning there's 0, 1, 2, 3, 4. So it's the same as the previous one, whether the 2 is present in this index or not. Can you find this in the index?
Yeah.
Yeah. So it will give you a true. Okay. Can you explain me what is this doing?
So this will be the value in the second index, is it?
No, no, it's just checking whether this particular value is present or not.
Oh, okay.
This 2 is present or not in index or not. In the
So
first,
here,
these two example, it was checking in the index if it is present anywhere here or not. If it was present, so it was giving you true. Now over here, I am saying that we want to check over here and the values. So this is my values, right?
mhm.
So can you see 2 anywhere over here? Can you see 2 anywhere?
Only 20 I can see, which has 2.
Yeah. So this is index. This is my value. Can we see 2 anywhere over here?
No.
No. So what will this give you?
False.
False, right? Okay. Now can I see this 20 anywhere over here?
Yes.
Yeah.
Yes. Okay. So what will it give you? True, right? This will give you true. So since it's written, let's save it. Okay. So it will give us false and true. Let's see the output. False and true, right? So most important thing is if I mention dot index, that means it is referring to index. Dot values, it is referring to values. If I don't write anything, right? If I neither I write index nor I write values, it means it is still referring to the index only, right? So two important takeaways from here. I mean, this is called as an index and this is called as a values, right? We have discussed so much time. And if I don't refer anything, that means it is still referring to an index, right? If I don't refer anything, it is referring to an index. If I write index, then also it is referring to an index. For value, I have to specify dot values. Okay, let's go. So I am defining a series over here. Series example 2 is the name of the series. PD, because we had imported pandas as PD. Series is nothing but a data structure that we are trying to create. This 10, 20, 30, 40, 50 is nothing but the values. 10, 20, 30, 40, 50 is the values. And DABCE, DABCE is the index, right? Whatever is this is the values, this is the index. This is going to print the series. So you can see that DABCE is basically the index. This 10, 20, 30, 40, 50 is the value. Okay. Okay. Let's look into this. Print, meaning you want to print something. Series example 2 is this. Dot sort index. So what will this do? Any guesses?
Yeah, it will sort the indexes like it will be A, B, C, D, E.
Sort the index as like A, B, C, D, E. So you can see that it has sorted the index as like A, B, C, D, E. Basically arrange the index in an ascending order. And what will this sort values do?
So this is to sort in the ascending order of values.
Ascending order of a value. So you can see that the value is arranged as 10, 20, 30, 40, 50. Okay. So 10 was D, 20 was for B, 30 was for A, 40 was for C, and 50 was for E. So what is the takeaway from here? You are having two particular functions. One is called as a sort index that arranges the series in the ascending order of an index. Of course, you can also do it by specifying false for a descending as well. So basically it is for sorting the index, and sort value is for sorting the values. Okay, any questions, anyone? Okay, no questions, then let's go to the example number 3. So example number 3, series example 3, we are creating a new data structure of type Pandas series. We are creating a data structure called as a series example 3. Data type is pandas.series. What are the values? Values, what are the values?
Like 10, 30, one null is there, then 10, 20, 40, 50.
Yeah, and what is the index?
D, A, B, C, E, F.
D, A, B, C, E, F. What is this going to do?
That will sort the index like from A to F, A, B, C, D, E, F.
Sort the index in ascending order, that is A to F. What is this going to do?
I think this will sort from 10, 20, 30, 40, but np.nan, that null will be at the end.
Yeah, null will be at the end. So this example is specifically put just to explain you that if there is a nan meaning not a number meaning a null value meaning basically you have written nothing in that particular cell. There is nothing in that particular cell in an Excel sheet, right? You can keep as a particular sheet cell in an Excel sheet as completely empty, right? So that empty cell means nan, not a number or a null value. So if you are having some null value, right? If I sort in an ascending order in an Excel also, the null value will come at the end. I'm not sure in Excel, if you sort, what happens? Null comes at the blank cell comes at the top or bottom?
I think Excel it comes on the top.
Excel, it comes on the top, right? Okay.
Yeah, even in COBOL, I think it is
Okay.
because
So in
of
Excel,
the
it comes on the top.
stake value.
But
But
in
here it
case of,
is ulta.
yeah, here over in the pandas, it will come at the bottom, right? So it's just to remember, null value will come at the bottom. The empty cell will come at the bottom. Okay, let's go ahead. Series example number 4. So it's again having a value as 10, 30, 30, 40, 50. Index is D, A, B, C, E. I'm printing this series, and we are going to assign the rank to each and every value. We are going to assign a rank to each and every value. That is, which is a rank 1, rank 2, rank 3, right? So let's say simple example of rank, right? Let's say you are having your you are having a marks of few students. Student 1 got 87 marks. Student 2 got 92 marks. Student 3 got 95 marks. Student 4 got 82 marks. Student 5 got 70 marks. So what will be the rank? How are you going to assign the rank over here? What will be the rank over here? Who is the first rank?
Student 3,
So this will be a rank 1.
then 2, student 2. And the first one is 83, right?
87.
87. Yeah, this is third.
4,
5.
5, right? So this is the rank, right? We know about a ranking system from our childhood, right? And this is a rank, right? So, and the same thing can be done in case of a series as well. You can assign a rank to a different numbers over here. Okay, so you can assign a rank to a different numbers over here. So this is a number 10, 30, 30, 40, 50. If I am assigning the rank method first, meaning, I mean, we'll discuss about method later on, but yeah, it will first it will assign the lowest number as a rank 1. Okay, so if you don't specify anything, it will assign a lowest number as a rank 1. So 10, 30, 30, 40, 50, 10, 30, 30, 40, 50. So 10 will be assigned a rank 1, 30 and 30 will be assigned a rank 2 and rank 3, rank 4 and rank 5, right? So if you don't specify anything, it will assign in an ascending order. Rank will be assigned in an ascending order. But the example just that we discussed for a student marks was in descending order, right? Highest marks get the rank 1. So over here, in case of if I specify the ascending as false, if we specify the ascending as false, if I specify the ascending as false, it is going to assign highest first rank number 1 to the highest value. So rank 1 is for 50. You can see that rank 1 is given to a 50, rank 2 is given to a 40, rank 3 is given to a 30 over here, rank 4 is given to this 30, and rank 5 is given to 10. So if you don't specify, the ranking is from small to big number. If you specify ascending as false, so ranking is from big number to small number. There is another thing that is called as a method. There is another thing that is called as a method, that is a max. So what this max is going to do over here is, what is this max is going to do over here is, if you are having the same number multiple times, if you are having a same number multiple times, this 30 and this 30, if you are having a same number multiple times, over here it was giving the rank 2 and rank 3, but it was the same number. So since it was the same number, what you can do is you can put a max method. So what this max method is going to do is, it is going to give the maximum rank. So 2 and 3, what is the max? So it is going to give a 3 over here, right? And this is the difference between a method max and what was a method first meaning was, first mean what? If there is a 30 and 30 over here, okay, this 30 and 30 was over here, the first 30 will get a 2 and second 30 will get a 3, 2 and 3, right? Similarly, here was also a 30 and 30. So the first 30 got 3 and second 30 got 4, right? So simply speaking, let's summarize these things. Let us summarize this. So this was assigning in an ascending order. Ascending order. So 10 got 1. This 30 and 30 got 2 and 3. 40 got 4. 50 got 5. It was in an ascending order of a mark, so it got a rank. Then we discussed about ascending as a false. That means in a descending order. So 50 got the rank 1. 40 got the rank 2. This got the same rank. And 10 got this rank. Okay, so it was a descending order. So this was about a descending order. Now, when we saw about an ascending order, this both 30 got 2 and 3. Okay. So the first, since we wrote the first over here, the first 30 that was coming over here, this first 30 got the rank 2. So this is the meaning of this first. But when I write this max over here, from 2 and 3, from the rank 2 and 3, the maximum of 2 and 3 was 3. So both of these marks got the rank 3, right? So this is about ranking. Any questions in this ranking?
Yeah, Hari. So in case of data wrangling, I think this concept is going to be used to, if you want to like rank some proper data and all. So which one will be like more useful, whether to use this method equals to first or method equals to max if data will be repeated and all?
You won't use many times rank. You won't use it many times.
Okay.
There is a similar way, right? Why you think it will be used first thing?
First thing is like there will be like huge amount of data for, but before going to any writing, any processing or machine learning algorithm for that, we need to like fix all those errors and all in the data, right? So that may happen. So in that case, So how this thing, if you want to use the rank thing, then how, like which one will be useful for that? That's what my thinking is.
Okay. Usually,
Because as you know, like in data wrangling only, we need, like we invest more time in machine learning.
right.
So yeah, so that's the thing I just want to add.
Right. Okay. Most of the times, ranking won't be used. There are two different things that is used commonly. Two different things are used. The one thing is if it is a alphanumeric value, a categorical value, let's say a male and female, right? For male and female, you can assign 1 and 0. So this kind of a thing is used. That we are going to see later on just after this. That's called as a dummy below. So just forget about it. It's called as a dummy or one-hot encoding. That's one thing that is used. We'll see it below. The second thing that is commonly used, I mean, why you use this male and female to 1 and 0 is because machine learning, it's all mathematics. It doesn't understand male and female. So it needs numeric values 1 and 0. So you need it one place. Second thing is for machine learning algorithm convergence, what it means and all we see later on. But meaning we see on a higher level. So again, you may need to convert the entire data between 0 and 1, let's say 0 and 1. Or if you're having a huge variety of a data, right? There's still not a very big variety of a data. So let's say you are having a multiple columns. Okay, you're having a multiple columns like age, salary, any other numeric column that you can, expense, credit card bill, right? So age can be 25, 26, maybe 50. Still okay. Age. Salary can range from 10,000 to 100,000. Expense can range from 1,000 to 10,000, let's say. Credit card bill can range from 1,000 to 50,000, let's say. So I'm just giving this example. So another thing that is used for a machine learning convergence is, so that algorithm converges very fast, is you convert everything into a similar scale. That is probably you bring all these values between 0 and 1. How do you bring it? Just divide by the maximum number. Just divide by maximum number. Just divide by maximum number. Something like that. So what happens is by doing this is all the numbers are between 0 and 1, meaning the same scale. They are in same scale. Previously, they were in the different scales. So since it was in the different scales, the algorithm takes little more time to run. To save the time, you may need a convergence. That's one of the data processing that is commonly done. Another data processing, I just said dummy or one-hot encoding. Ranking is not much done from a machine learning perspective. At least I have not seen many times ranking being used. So it can be used in a time series sometime, but it won't be used much. Ranking won't be used. These two things will be used a lot. The first thing is converting this male and female to zeros and ones. And second thing is this is a huge variety of a data in a different scale, 10,000 to 100,000, 1,000 to 10,000. The scale is different. So bring it to a same scale between 0 and 1. How to bring to a same scale? Divide all the age from the maximum age. You get something. Divide all the salary by the maximum salary. Divide all the expense by maximum expense. Everything will be in the same scale, so it will be fast. So again, just forget it. What we discussed now, we are going to anyhow see all these things in much more details. But just to say that no, rank is not much used. Again, if you want to use a ranking for some data analytics, you want to put a rank and make some reports and show that what is the ranking of it. then yes, you may need the rank, as we discussed for the student marks. So you want to show that the who has got the highest marks, or who is, I mean, you want to arrange the top performers, sales. So which particular sales executive brought more sales? So for those cases, you may need ranking. Obviously, you will be needing a ranking that is called as ascending falls. Yes, but not much from machine learning point of view. And if you need for a data analytics, it will be highly based on the use case what you are solving. Okay.
Harish, two more questions. Two questions. So basically, if you don't give any the method, in the bracket, so which method it will take by default?
It did not. It. Okay, that's a good question. Let's try. I think so. It should take first only. It should be the default one. Let's try. Oh, it takes the average out of it, 2.5, 2.5.
Okay, so
Okay.
10, meaning first, but 2.5, 2.5.
Yeah. So it was previously it was 2 and 3, right? 30 and 30 was 2 and 3. So average of 2 and 3 is 2.5 and 2.5. So it just took 2.5, 2.5.
Okay. And one more question: why rank is like a floating data type? It shouldn't be integer.
You
Shouldn't it be
can
integer?
convert it into an integer later on. You can
Okay.
add as a new column and just convert it into an integer.
Okay. Yeah.
Okay. Any other questions, anyone? Okay. If no questions, let's go ahead. So let's see this one. So we are defining a series, example number 5. The values are 10, 30, 30, 40, 50. The index value is AABBC. So you are having a duplicate index, as you can see over here. A is 2 times, B is 2 times, C is 1 time. Then we are saying that series underscore example 5. If I just write series underscore example 5, I will get everything. If I write series underscore example 5 dot index, what will I get?
All with the index value, right?
All index value, that is A,
Yeah.
A, B, B, C. So is unique? Is it unique or not?
Not all are unique.
Not
So
unique,
A,
right?
B, C.
So it is not unique. So it is what it is going to give you is a false. It is going to give you as a false. So you can see that you got false. Okay. So just write this so that okay. So it says that it is false because A and A index is not unique. If it was all unique, it would have given as unique. Okay. Then going to this one, series.eg loc. Okay. So there are two important functions or methods that's called as a loc. That's called as loc and iloc. Okay. There are two things called as loc and iloc. So what is this AABBCC? AABBC, what is this?
Index.
Index. What is this?
Value.
Value. Okay. If I want to refer to any of these things, series example 5, if I refer directly, if I want to refer to any of this particular index, let's say I want to refer to this B, I can simply give it as series example 5 is equal to, is in bracket B. So what will this do? Series example 5 B is going to print these two things. This is B, right? This is B. So it is going to print these two things. But there are two other methods which you can use, LOC and ILOC. So LOC is doing nothing, but you can still specify the index like this one. That is, you specify as B. Okay. So what is this series example phi dot LOCB is going to do is it is going to give you these two values. It is going to give you these two values. So either you can do it this way, series EG phi dot LOCB and series EG phi B, it is both going to give you these two values. Okay. Both of these things, both of these example is going to give you the same thing. It is going to give you 30 and 40. It is going to give you 30 and 40, B30, B40. Both these things are going to give you same thing. You can either do it this way or you can do with a dot LOC. There is one more thing that is called as a ILOC. Okay, there is one more thing that is called as a ILOC. So in ILOC, what do you specify is, instead of specifying the index name AABBC, what we have specified, you specify the index number. You specify the index number. So what will be the index number for this one? If I want to talk in terms of number,
0,
0. What will be this number?
1, 2, 3,
1,
4.
2, 3, 4. So there is another thing, LOC, you specify the index, whatever is the index. And ILOC, you specify the index number. Okay, index number. So if I want for B, that is B is at the two places, then I will have to write 2, 3. Okay. So there are two methods that you have to remember. You have to remember it well because the same thing continues in data frame and same thing you need it for any kind of a thing. So you put in your brain properly. If you can just specify it, it still works. You can just specify directly, it will still work. You can also give it as LOC. Both of these are going to do nothing but going to print this both of the things, right? So just remember, LOC and without LOC is one and the same thing. And what is ILOC? In ILOC, you are always going to give a number index. You are always going to give a number index. So what is the first thing? You specify LOC or don't specify LOC, one and the same thing. What is ILOC? ILOC, you are going to give the numbers. Okay. So just keep this in your mind properly, and this is very important takeaway. If you forget it, it will end you up in trouble. More basic, I mean, it's the most basic thing. So as I said that if I give this way or this way, both the way, it's going to print the same thing, right? It is going to print the same thing. It's printed the same thing for the second one and for the first one. Okay. So which one should you use, with LOC or without LOC? Any guesses?
Actually, if we are defining index, then better use LOC, right?
Better use LOC. Okay. And you're defining index or not defining index, in both the cases, always prefer to use LOC. Okay. Always prefer to use LOC. Always use LOC. Okay. This is, I mean, there's a big problem. I mean, in Pandas, you will see that as we go further, and I have also tried to cover the things more exhaustively. What are the different ways you can do the same thing? You can do it with LOC. You can do it without LOC. And there are other many things that you can do it in 2 ways, 3 ways, 4 ways, and 5 different ways. Most of the things, 5 different ways, you can use any of the 5 different ways. It will still work. But for LOC and without LOC, if someone else is writing, you should be able to understand what it means. But if you are writing, always use with .loc. The reason for using with .loc is LOC supports wide range of other functionalities as well that is not supported by this syntax, right? If you want to locate something, multiple things, multiple indexes, and so on, You can easily do with LOC by this syntax. But this syntax, you can only do the limited thing. So the question is why the Pandas kept it over here? Because it had to keep the old Python syntax, right? Because in a Python, if you want to, or not just in Python, in any programming language, if you want to refer to any element in an array, you should have some, this was the syntax. So it just kept this syntax as well, maybe for beginners, and it has not removed it. But the good way of doing is using LOC. The reason I already told you, because LOC supports a wide variety of different ways to specify the things that we are going to study later on, right? So it's a very important takeaway. If I say B, it is only going to give this BB3040, which is given me over here, this BB3040. And if I use it without LOC also, it is going to do this. But what is the takeaway? You should always code with LOC. And if someone else is coding, then you should be able to understand what the hell he has written, right? Okay, let's go ahead. Series example B. So what is this going to give me? Only this thing. What is this going to do? What will be the output of this?
30, 40.
B30, B40, right?
Yes.
Yes.
B30, B40. If I put a values on top of that, then what will be the output?
Only 30, 40.
Yeah, only 30.
Only
40.
30 and 40, right? Because you are saying that I only want the values. I don't want index, right? So just start looking like this. So you will get 30 and 40. And what will this toList do if I add in front toList?
It will convert to list.
Converts
Yes.
into a toList. So you can see that a list is converted, right? So start looking from small piece of code. It is giving me B30, B40. Okay, I'm happy with this. I understood with this. And what is this doing? It is only giving the values. I don't want index. So it is giving me 30 and 40. Okay, I understood this. I'm happy. Then finally, what should the toList give? It should give me a list of it. It should give me with a square brackets. Okay. And any moment of time you don't understand anything, just simply remove the things and execute. Just simply remove the things and execute. Okay, this gave me 30 and 40. Okay, what happens the moment I write the values? Moment I write the values, I still get 30 and 40. It still has a list. Okay, so writing a toList is doing nothing great. Still giving me as a list. Still giving me as a list. But what was the difference? Any difference? It is still giving me a list, right? So this particular function, even if I don't write it, it is still okay. Okay, so it is doing the same thing. So just understand, if you don't understand anything, just remove a piece of it and see what is the output. Okay, let's look into this one. Series example equal to 30. So series example equal to 30. So let's understand what will be this. Is it equal to 30? Is this 10 equal to 30?
No.
So it will be false.
False.
This will be
True. True. False. False.
false. So these two are true. So if I just write this piece of code, if I just write only this piece of code, I am going to get something like this: false, true, true, false, false. The moment I write this particular data frame, it is going to show me everything that is for true. That is for A30 and B30. So it gives me A30 and B30, right? So is this clear? Anyone having any doubts in this? Okay, no doubts. Let's go ahead. So this was giving me true, true, false, false. This entire thing was giving me this thing. If I write dot index, then what will it give me?
A, B.
A and B, right? It will give me A and B, and I convert it into a list. So it gives me in a list A and B. Any question, just stop me there and ask. Okay, let's go ahead. hierarchical indexing, multiple index, or two or more index. So let's try to understand this as well. So it is saying that we are studying about a multiple indexes. So what is this?
Series value.
Values. And what is this?
Index, two
Index.
indexes. Is
Can
it?
you see there is first list of index and second list of index? So it's an hierarchical indexing or multiple indexing. Again, in practical, you won't use it multiple a lot, but yeah, this is also possible. So this is my first level of index, I1, I1, I1. Can you see this I1, I1, I1? So this is this I1, 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 ABC. So the first three values. Again, this I2, I2, I2. For this, again, there is a ABC. So I2, 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 ABC. Again, there is I3, I3, I3. Again, there is ABC. This is I3, 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 and ABC. The values are same 10, 20, 30. So you can see 10, 20, 30, 11, 21, 31, 11, 21, 31, 12, 22, 32, 12, 22, 32. Right? Any questions in this so far? So you can have a multiple level of index. So you want to refer this thing, then you have to say this dot this. Okay. So let's say I want to refer to this 20. Then how will I say I want to refer to this 20? 20 is at what index?
B. I mean, 1.
I1 dot B. Right?
I1 dot
I1
B.
and what? Where is this 31?
12 dot C. I2 dot C.
I2 dot C. Right? Inside I2, inside C. Right? Again, multiple indexes you won't use in practical, but this is something that is possible. Sometimes you may use, but only for seldom. Okay.
So in this case, like this, multiple index has to be unique also.
No, it can have
Effectively,
duplicate.
okay. Meaning like I1, 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 and there we can have ABA.
Yeah, you can have. Okay, so if I say I1A, then what will be printed now?
10 and 30.
Yeah, this one and
Both,
this
is it?
one. Yeah.
Okay.
Okay. So if I say dot index,
Harish, if you put directly A in
where?
only A instead of specifying I1 dot A.
Yeah, like lock A, right? Location A, for
Yeah.
example.
If you just specify location A, it won't give you a result. It won't follow. It won't know, right? You can try it over here. Series dot log.
Okay.
Correct. It gives some error. So you have to
Error because
specify
it's like because it's not unique, or it is multiple indexing is there.
so it is no index, right? No, you don't have A, right? Okay. So if I give I1, I'm able to find it. Because first it is referring to the first index, right?
Mm.
You can always specify directly A also. We'll see after this. If you want only A, then you say that first index is everything and second index is A. We see after this example. After this below, that's the example. Okay, series example dot six dot index. What will it give? What are the indexes over here?
Meaning all I1, ABC, I2,
I1,
ABC.
ABC, I2, ABC, I3, and ABC. If I say dot values, then
10, 20, 30, 11,
10, 20,
21,
30,
30.
11, 12, whatever, 30. Okay. Then let's see how to refer to a particular elements. Refer to a specific element. Let's run this. So what will this, if I say I1 only, then what will be printed?
3 values, right? 10, 20, 30. I mean, yeah.
Do something so that it's easier to understand. print dash series example series underscore EB6. Okay. So this was my original series that I have. I1 is having an index ABC, I2 is having index ABC, I3 is having index ABC, 10, 20, 30, 11, 21, 31, and 12, 22, 32. This is my original series. If I say I1, then what will be printed from here? I1, what will come from here? Locate I1 or I1. What will come? What will this give you?
All ABC index.
So it is going to give me, if I say that I1 I want to find, so this is going to give me this particular part. That is ABC and 10, 20, 30, right? ABC and 10, 20, 30. If I give this way or this way, is it giving the same output or a different output? If I'm writing series underscore EG I1, or I'm using series underscore EG dot LOC I1, is it giving me same output or different output?
Same output.
It is giving the same output.
Same.
It is giving the same output. But what is the thing that you should always use? Without
LOC.
LOC or with LOC?
With LOC.
With LOC, right? So that your syntax is there in your mind and you don't tend to write this where it is not possible. Always use LOC. Okay. So this is giving the entire elements. Okay, let's go ahead. So if I say this one, I1 A1 and I1 A1. So what is this going to give you?
10.
I1A and I1A. So I1 is over here. A is over here. So it is going to give me 10. Right? So you can see that 10 is printed. 10 is printed. So series EG 5 I1A, I1A, it is going to give me 10. Okay. So shall I use with LOC or without LOC?
With LOC.
With LOC, right? Okay. If you see this one also, this is also giving the same output 10 and 10. Can you explain me what is the difference between this and this, the above piece of this code and this code?
In the above, you have used 2 square brackets.
Over here, we have used two square
2 square
brackets.
brackets. Here,
Over here,
within a single list, you mentioned the I1 comma A.
I1 comma A. Okay. So there are two different syntax in which you can write. Okay. So whichever syntax you feel comfortable with, you write with that particular syntax. You want to make a 2 square bracket, you write it that way. You want to make a 1 square bracket, I mean a single list with a comma, you can do it in that way. Both essentially means the same thing. I want to locate A inside I1. Inside I1, I want to locate A, right? So both does the same thing. So different syntax, don't get confused. In Pandas, there are 10 different ways of doing the same thing.
But in NumPy, it was like rows and columns, right? I1, A, meaning in NumPy.
Mhm.
In NumPy, it was like if you put a comma, it will be a row, comma, column.
Yeah, because NumPy was an
It was
n-dimensional
array.
array, right?
Okay.
It was an n-dimensional array. So here also, as you go into a data frame, you will get the same thing. As you go
Okay.
into a data frame, you will feel it that it is same as that. Because NumPy, we were discussing about n-dimensional array, maybe a 2-dimensional array like a matrix.
Okay.
Yes. And in fact, NumPy was not even having a 2-dimensional index over there. I mean,
Yes. Yes.
NumPy was not even having a multi-dimensional index. Okay. So meaning to say that pandas will look confusing to you for some time, but it is just because that there is a different ways of doing the same thing. It will come with a practice, or if you want to practice, you practice this notebook many times. Okay. Let's look into another example, refer a range of elements. Again, let me print the actual series, print series underscore EG6. Okay, let's look into this. This is my original series. Okay, you try to answer me what it is going to give. Okay, anyone, can you answer me what is this saying? Series underscore example I1 colon I3, meaning what? It is same as arrays and list. List also we discussed in Python. What was this colon meaning?
It is for the range. We'll specify. We want it from I1 to I3.
You want to specify the range from I1 to I3. So you are specifying a range I1 to I3, right? A range I1 to I3. If you're not speaking, please mute. There is a lot of sound. Okay. So this is I1 to I3. You can also do it with LOC. So this and this is the same thing, right? We already know these two are the same thing. LOC and without LOC essentially mean the same, but always use LOC because LOC supports more functionality as compared to without using LOC. So it is also going to give I1 to I3. What is this ILOC? ILOC nothing colon 10.
Meaning from 0 till 10.
0 until 10, right? Meaning 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So it essentially does the same thing. ILOC is doing nothing, but it is giving you the index, right? And we had discussed previously that the index is going to start from 0. It's a 0 at index. This is the first index. This is the second, third, fourth, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6, 7, 8. So there was no need to write 10 also. I can also write it 9, right? So it is going to give until that. So it is basically going to give from 0 until that particular index. So let's see this one. It is going to give you everything. Let's say if I change it till a 9. Where is it? Nine. So 9 is this one. It still gives me everything. If I write until 8, if I write until 8, it is only giving till B. Why it is not giving C? It is only giving till B. It is not giving C. Why? If I write 8, it is only giving till here. If I write 8, it is only giving till here. Why?
Because till the 9th occurrence, right? Effectively 0
So
to
this
8.
is 0, 1, 2, 3, 4, 5, 6, 7, 8. So if I write 8, it is giving till here. Why? Why it is not printing this?
Because it is until 8.
It is until 8, right? Until 8. So it will only give till 7, right? So that's why it is only printing till B22. It is only printing till B22. It's only printing till B22. So you have to write at least 9, right? So if you print until 9, then it is going to print everything. So this is the way how you can specify the range of the elements. I want from I1 to I3, or if I'm giving in an index, always remember for index it will be until. So it will be 0 until 9. Okay, let's go ahead. Let's go ahead. What is this? What we are doing over here? Just forget about this. This is commented. Just forget about this. Can anyone explain me by looking into this what will be the output? This is my input series. This is my series. What will be the output for this command?
I1 index A and I2 index A.
10, 11, 12.
So it's saying I1 till I3. So it is saying that I want I1 index, I want I2 index, and I want I3 index, all three index. And what is this saying?
A in all the.
I want only the A. So A10, A11, and A12, right? So it should be clear, right? I1 till I3. So outer index, it wants everything. Inner index, it only wants A. So 10, 11, and 12. So let's see the output. So you can see that 10, 11, and 12. Any doubts in this so far? Okay. If I write without LOC, if I write without LOC and try, if I try without LOC, right? Without writing LOC, if I uncomment and see if this works. So it is giving me an error, right? It is giving me an error. So this is not supported, right? I cannot do it like this for a multiple indexes. So if you are working on a multiple index, always use LOC. Always use LOC. Is it clear? Always use LOC. That's why I said in before also that not all functionality is supported without LOC. So if you are working with a multiple index, always use LOC. In fact, if you are working with a single index, also always use LOC. It is always on the better side that when you are going for an interview and he asks you some crazy questions, you always do with LOC. He want to trouble you, nothing else. So you always use LOC. Okay. Next thing, yeah.
So in example 6.loc I1 colon I3 comma A, in this case I3 is until, I3 is also included, it's not until.
Yeah, if you specify the index, then it is until.
Okay.
If you specify the LOC, then it is not until. So if it is ILOC, then it is until.
Okay, understand.
So if it is ILOC, I over here, then only until. Okay. Then talking about without LOC and with LOC, always use with LOC because some of the things like this example is not supported. Again, with this is a two bracket, right? Over here we saw that you can give as a comma or you can give with a two bracket. Okay, you can give it a comma, you can give it a two bracket. But over here, if you see over here, comma one, it works. But if you are giving with a two different bracket, it is still not supported for multiple index with a range. Multiple index with a range, two bracket is not supported. So that's why I have commented this piece. If you run this one, this is obviously going to fail. This was failing above also. But seeing this red line means it failed over here. It failed over here. So it doesn't support. If you just uncommented and try like this will also fail. You can see the red line over here. You can see the red exclamation mark over here. And you can see that there is some error that came. So always your preferred syntax should be, yes, right. No, your preferred syntax should be dot loc, and after loc, what actually your preferred syntax will be loc, and whatever you are writing with comma, right? So always keep this preferred syntax, right? Always use loc, and with loc, instead of making two bracket, use a one bracket and a comma, so that it works for almost everything, right? So you use this syntax. Other people are using other syntax, it's okay. Or if you are doing a code review, and there is nothing called as a code review in data science. It's either you get a result or you don't get a result. So there is no question of code review as well. So anyhow, you have to use LOC better. Okay, let's look into another example. This is what is this? What is this data type in a Python? What is this data type?
Integer.
List.
A list, right?
List.
Or list. Okay.
What is a data structure? Okay, not data type. Okay, good. So it is a list data structure. What is the internal data structure? Which is the internal Python data structure? that I've highlighted over here? What is
Dictionary.
this data?
Dictionary.
Dictionary. Okay, perfect. We are making a series out of a dictionary. So exp salary, experience salary is pandas dot series. I'm creating a series salary. So this is the dictionary you copy over here. Dictionary that you copied over here. And this is the index that is exp 1 0 2 3 4 5 6 7 1 0 2 3 4 5 6 7. So pd dot series salary and index is equal to exp. So you have created this particular series exp underscore salary. So so that's created. Okay, the sequence will be this one: 1 0 2 3 4 5 6 7 1 0 2 3 4 5 6 7, because experience was specified as an index. Okay, can you tell me why this 7 is NaN? Can anyone tell me why this 7 is NaN? Why this 7 came NaN?
Because index are more, and those are 8 values, and in
No, there is no 7 in the
salary.
dictionary.
There is no 7 in the dictionary, right? So this is my values, right? This is my values. This is my value, this is my index. So in the value, this was my value. There is no 7. So there is no 7 in my value, but the 7 was present in the index. Since 7 was present in the index, it has to come. But since there was no value, that it did not come. Okay, let us discuss more. 8 is 58. So why this 8 did not come?
Because yeah, in index 8 is not there, and the like index is depending upon the experience, and inside the experience 8 is not there. That's why
Okay.
it didn't come.
So value is present, but the index is not present. Okay, so this 8 did not come. Very good. Okay, why the 6 came as 14, did not came as 15? Why 6 did not come 15, it came 14, why?
Max of index.
Not really max. So index is 6 for this particular 6 index that is shown over here. It shows as 14 and does not show 15, why? Yeah, I mean, yeah, max of index. I mean, whatever comes, I mean, if you are trying to say that whatever comes late in the
6
last
is
in
again
the
redefined.
dictionary. So it's a dictionary, right? This is a dictionary. So dictionary cannot have a duplicate keys. So if there is a duplicate keys, it will take whatever is the last value or whatever is the latest value. 15 followed by 14. So 6 was written over here 2 times, 15 and 14. So it takes the latest one, 14, right? So
Harish, I have a question. I just want, here we are specifying this is dictionary, right? So dictionary have its own index. So we are specifying the index to this one. So how does it matching, like is it mapping the key value with the index we are specifying, or how is it?
okay, let us come to that. So I just write the first answer what we discussed. Why 7 is NaN? Because 7 key value, because 7 is not present in dictionary. 7 was present in index equal to exp list, but not present in values is equal to salary dictionary. Okay, so first question was why 7 is coming as NaN. So the answer is because 7 was present in the index, so it is coming. Since its corresponding value was not present in the dictionary, so it is not coming. It's coming as NaN. Question number 2 was why 6 got value as 14. but not 15. Okay, it was present over here. So question number was 2 was because it was present over here. Answer was since salary is a dictionary and it cannot have duplicate keys. It just retains the latest value 14 in this case. Question 3 was why 858 is missing. Answer 3 was because 8 is not present in the index is equal to exp list. Okay. So these were the 3 questions and answer. What are you saying now? What was your question?
I'm just asking, like, in case, because we are earlier we had list, right, and then we were specifying it with the index. We were providing the index, then it was mapping the value directly with index. Now here, if in case of dictionary, if we are specifying the index, would it map with the key values? Is it work like that?
Will it what?
We have provided this index, right? Exp as index.
Yes.
So is it mapping these index value with the keys of dictionary?
Right. It is mapping with the keys of dictionary, right? So first was a 1. So for this one, there was a value as 9. So it printed 1 as 9. So second was 0. For 0, it was 8. So it printed 0 as 8.
Yeah. So basically it works different with the list, because if it is a list, it will directly map with the values, right?
Yeah. If it is both the
In
things
the
are
sequence.
list, then it will just take the sequence wise. What is the sequence it was available? But if it is a dictionary,
in case of dictionary, it doesn't take sequence.
Yeah, if it is a dictionary, it will take the sequence from the index and map accordingly with the dictionary.
Key values.
Yes. Right.
Okay. So okay, understood. So here, if we mention like in exp, if we map something ABC something, it won't print, right? It won't work. That key value must be present in the dictionary.
All right. So if you write anything other than this, then it will say that 10, 15, 16 is 9.
Okay,
Because
understood.
it's not present.
Thanks, sir.
Okay, so let's go ahead. Is null. So what is this going to give? What will be the output for this? Is null. Can you see any null over here?
Yes, the last one.
Last one. Oh, why is this giving 10, 15, 16 null? Because I just executed. That's it. Okay, so only the last one should be null, right? Only the last one should be null. Okay, straightforward. Let's go ahead. What are we doing over here? Can anyone explain what are we doing over here?
We are assigning the values to null, like the 0th index and first index are assigning as null.
Okay, now I'm changing to 0 and 5. So I just change it to 0 and 5. So you can see that for 0th index and 5th index, it's going to assign a null. Okay, so 0 and 5th also became a null. Okay, if I say this way, is it a .loc or .iloc? If I don't specify anything, it means .loc or .iloc?
.loc.
.loc, right? This is .loc. Right? So if I don't specify anything, it means .loc. Okay, if I do .iloc, then what will happen? Let's say if I do .iloc instead of doing .loc and iloc, if I did loc, this and this element became null. If I do .iloc, then what will become null?
First one means
Sixth
the
occurrence,
value,
right?
the index one. Yeah,
This
one
one
will change to
this one
and the
this
number
one?
4. number 4.
This one, right? This one and this one, right? So this one and this one, right? This one 0, 1, 2, 3, 4, 5. And this one, right? 0 and 5, this one. So this was at the 0 at index, this was first index, second index, third index, fourth index, and 5 index. So always remember, never get confused with .loc and .iloc, right? Never get confused with .loc and .iloc. Okay, so never get confused with LOC and .iloc. Okay, so just understand over here. If I want to, let me add one more example over here, right? When I say .iloc, let me write it as .iloc, ILOC file. Okay, and let me execute this as well. Okay, so just understand what it means. So this file was already null, so let me make it for 3. So 1, 2, 3, no, 4, 5, 6. Let me make it for 0. Okay, so just be clear about if I don't specify anything. If I don't specify anything means what? If I don't specify anything means what? Is it LOC or .iloc?
LOC.
.loc. Okay, if you don't specify anything, it is LOC. Okay, so when I say LOC, meaning this value, this is my 1, this is my 0, this is my 2, this is my 3, this is my 4, this is my 5, this is my 6, this is my 7. But when I say .iloc means it's my internal location or internal index, right? So what will be this internal index? This one, what will it be?
0.
0. What will be this one?
1, 2, 3, 4, like that.
1, 2, 3, 4, 5, 6, 7. Okay. So LOC is what you see. 1, 0, 2, 3, 4, 5, 6. Whatever is it. It may be in a sequence. It may not be in a sequence. It can be duplicate. It may not be duplicate. It can be whatever, multiple indexes. It can be whatever things, right? But when I talk about I, it's always internal and it will always start from 0 and it will never be repeated, right? So this is 1023. It can be anything, right? We already saw a lot of things about LOC and ILOC. So keep this ILOC in your mind very clear. When I say .iloc, I mean to say that I am referring to the internal indexes. Okay, and when I just say LOC or if I don't specify anything, that's the index that I see in front of my eyes. Any questions in this? This LOC and ILOC, I'm repeating and emphasizing a lot of times. It should be very clear. Okay, let's go ahead. So what is this going to do? Drop NA. What is this going to do?
Like it
Null,
will drop
drop
the
null. Yeah.
null values.
It is going to drop all the null values, right? So some of the functions, even if I don't cover, you should be able to make it out. Simple, right? Drop null. So this and this is gone. This is gone and this is gone, right? Whatever was a null value, whatever was NaN, that is whatever was true over here. So whatever was the null value over here, it has dropped it. Whatever is the null value, it will drop it. And what will this do? What is this doing? I mean, it's doing the same thing as above. But can you explain me how it is being done? This was very simple. You can read it out and do it. But someone decided, or let's say someone is asking you, you want to drop the null values without writing drop NA function. Then how will you do?
Do we have like not valid kind of command?
Okay, so can you explain me what will this not null do?
It will
Okay,
find
this-
all the values which are not
which are-
null.
It is going to return you whatever values that are not null, right? So not null, it's like opposite of is null. So it is going to give you whatever values that are not null. And then finally, for those true values, you want to see, right? So this is a different way of doing the same thing. I mean, if you find it simple, you can use it drop NA, or you can also do it this way. So how to understand this? To understand this is just execute this piece of code. So what will this piece of code give? It will give you all the rows that are not null as true. This will give all the rows that are not null as true. And correspondingly for that true, it is going to give you the entire data frame, those particular rows of the data frame. Any questions in this so far? Okay, if no questions, then let's go ahead. Again, we are defining another series, EXP age. So experience is 1, 0, 2, 3, 4, 5, 6, 7. And we are giving some age to each of these people. We're giving this age to each of these people. We are adding this to series. The first series was experience salary that I was working on the top. And there is another series called as EXP age. And if you're adding, it is going to add the index 1 with index 1. If any of those are null, null with anything will become null. So if I print the value of this, right? If I print the value of this, EXP salary I was having from above. So if I add this 31 plus null, I will get null. 30 plus null will get null. 33 plus 7 will get 40. 35 plus 8 will get 43. 36 plus 9 will get 45, and so on and so forth. So this is how you can add two series. Okay. So this is about how you can add two series. You can do similarly any mathematical operation for each and every element in a series, plus, minus, whatever. Okay, so this is my series EXP8 so far. What I'm doing over here is EXP age dot name is equal to age. So what I'm going to do is I'm going to assign this particular column in that series. I mean series, this particular column that is present in a series with the name as age. And I'm going to give the name to this particular index as EXP. Okay, so if I try to do this, and if you look the above one output and this particular output, you can see that the name of the index is EXP. You can see that the name of our index is EXP over here. The name of the index is EXP. Similarly, age over here is the name of this particular column that was having a float values, float 64 values is age. Before there was no name, right? So this is how you can give the name to the index as well as the columns. So if you want to give a name to a particular index, you can say that series dot index dot name is equal to this. And if you want to give the name to those values, you can say that series dot name is equal to age, right? Any questions in this so far? Okay, if no questions, then can you explain me what will this command do? What will this do? Change index exp age dot index is equal to idx abch. What will this do?
Assigning the new index,
Assigning the new index. What is the index?
index name only basically.
IDX A, B, C, D, E, F, G, H, right? So this 1, 0, 2, 3 till 7 will change to IDX A, B, C, D, E, F, G, H. So I'm changing the
Yeah.
name of the index, right? 0, 1, 2, 3, 4 to IDX A, B, C, D, E, F, G, H. So this is how you can change the index. Let's go ahead. Can you tell me what will this do? EXP age. EXP age is nothing but this one. Dot drop IDX A, IDX B. What will this do?
It will remove the first and second index values as well as index.
So what will it remove? This too?
Yeah.
So it is dropping the IDXA and IDXB. So EXPH dot drop IDXA, IDXB, taking the output in EXPH drop and just displaying it. So you can see that A and B is dropped. Index A and index B is dropped. Okay, let's go ahead. EXPH drop. So EXPH dot drop. So over here, it's little bit complex. But can you just look and make out what is this doing? Can you tell me what is this doing? Just look into this is my data. This is my data. If I run this particular thing, what is it trying to draw? What is it dropping? Can you just look and say what will it drop?
Index 0.
No, not index 0.
IDXD.
I think
IDXD,
first it will
yes,
find,
IDXD is correct. Why
first it will
IDXD?
try, first it will try to find out where the like age is equals to 35.
Okay.
Then it
So
will,
you are saying that first you will find out age is equal to 35 because you saw this.
yes.
So then what next you are saying?
Then it will find out the index and then it will drop that.
Okay, so it is basically going to give you true and false. So whatever it gives true, it is going to take that display. Then for that, it is going to locate what is the index. If you want to locate an index, it is like this. And basically you are going to drop 35, right? So what we are doing over here is, you guessed it correctly or you interpreted it correctly. It is going to drop this particular row, the row with having IDXD and 35. But it is something very difficult to understand if you are looking for the first time. Then how do I break this code and understand? Okay, you said correctly, it is going to drop 35. So how I am going to understand? So first thing I want to understand is I will see the most innermost bracket that I can interpret. So this is 35. So I just write exp age is equal to yes equal to 35. So what is it giving? This one, right? Because this was having a 35, others was false, 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 false. So it is giving that false, 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 true, false, 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 false. Okay, if I do like this, what is this giving? It is only giving for that true IDXD and 35. IDXD and 35. So how is it executing? Python is executing internally this way. Okay. Then what was the next step? So next step is to add the index. But if I just add the index dot index, it doesn't give me properly. I mean, it is giving me in this particular format. But I only want this thing. So I say that index as 0. So it gives me IDXD, right? So what is this effectively? IDXD. So it is effectively, instead of writing this, I am writing IDX space D, right? I am writing this IDXD, right? So it drops an IDXD. But is it written this way? It is written this way, right? So you may find it little bit difficult to interpret the things, but what you need to understand is this kind of a functionality is possible. You can find a particular value and you can delete it, or whatever you think of, it should be possible one way or other. Then how to do it? You can always go and Google it. You can always refer to this sheet. And if you are at the level number 3, you should be able to write by yourself, right? So objective of this course is not to go to level 3. Level 3, step 3, you will only go after 1 year of experience. After 1 year of experience, it will look like a piece of cake because you have done it 10 times before. But at this moment of time, before going for interviews, before applying for jobs, before understanding, you should be at least at the point of time wherein you should be able to look into a code. You should be in the step number 2. You should be able to look at the code and interpret what should be the output by yourself. And if you are not able to reach over there, just break the code and execute. Break the code and execute. Break the code and execute. And finally, you will be reaching over there. Any questions over here? Why the index D was deleted?
Why you mentioned 0 there, Harish? Index of
If
0.
you don't mention 0, you can see over here, right?
Instead of 0, if you mention something 1 or 2,
it will say 1 doesn't exist. So if you do this way, if you do 1, then it will say it doesn't exist because it's only one element that is present.
So single element, okay.
Yeah. Yeah.
So in case if the IDX D is 2 times, then it will be having 0, 1, right?
IDX D is 2 times, yes, it will have 0, 1. Yes.
Okay.
Okay, so let's go ahead. I mean, it's a little bit difficult to interpret, but yeah, you have to reach to this level. If you are finding it difficult to understand, just try to execute line by line what output it gives. Then let's go over here. Another duplicate index label. So this is my values. This is my index A, B, C, E. This is my name of the example series, example 7. A, B, B, C. Okay. Have I used it further? No. I think so. We can remove it. We have already discussed it above. Duplicate index, we have already discussed it above. I just remove this step one. Okay. Any questions until now? Anyone? If no questions, then we are done with the series. The next part is data frame. So we'll take a quick break. The time is 11:45. We'll come back at 11:50. If you are into a different time zone, come back in 5 minutes from now. Okay, so let's get started with the data frame. So data frame we already discussed in the sheet, but let's discuss again. So data frames look something like this. This side will be my index, or you can call it as a rows. This side you can call it as a values, or you can call it as a columns. Again, saying that you can also call this as a axis 0. You can call this as a axis 1, right? So this is how data frame looks like. So you are having a column 1, column 2, column 3. For simplicity, let's assume that the index is directly 0, 1, 2, 3, 4. Most of the case, it will be 0, 1, 2, 3, 4. However, you can also give it a name. It can be a repeated, it can be a multiple index, and so on and so forth. So this is how a data frame looks like. It is very similar to a Excel sheet, right? So what are the things that I have to remember over here? This is a rows, can also be called as an index. It is a axis 0. This is a columns, can also be called as a values, and this is a axis 1, right? So just remember this thing as we discuss a data frame. This picture should be always in your mind when we are working with a data frame. So this is my data frame. Let me save it. And let's discuss over here. So like pd.series, you are having a pd.data frame. pd.series, you are having a pd.data frame. Now you are defining something over here, and let's try to interpret. Let's try to be on the stage 2 or step number 2, stage 2. By looking into a code, am I able to interpret the output or not? So let's try to look into this. So I am saying that you want to make a data frame. The name of the data frame is df1. The name of a data frame is df1. Let me add some text rows over here. Text rows. Oops, dirty. Let me add some code rows over here. So that I have some blank space to write. Okay, let me write over here. So what we are saying that we are creating a data frame over here, df1. I am going to explain for a data frame 1, data frame 2, you have to explain. So listen properly. First of all, what is the shape of this particular data frame?
3 cross 3.
3 cross 3. So can I say it will look something like this? Okay, these are my columns. These are my rows downwards. And 3 cross 3, meaning that I will be having 3 rows, 1, 2, and 3. See, 1, 2, and 3, 3 rows. And how many columns?
3 columns.
3 columns. So again, 1, 2, and 3. So first column, second column, and third column. So this is my entire data frame content. Okay, this is what I have written. So the shape was 3 cross 3 that I have drawn over here. Next thing, can you answer me? What is the name of the index? What is the index?
Row indexes are R1, R2, R3.
R1,
R2 and R3.
R1, R2, R3. This is my R1, R2, R3 that I have drawn over here. This is my index. What is the name of a columns?
A, B, and C.
A, B, and C, because I have said that list of A, B, and C. List of A, B, and C effectively means that A, comma, B, comma, C. Okay, so this is my A, B, and C. So this is my first data frame. Very good. Then what will be the values inside it? What will be the values inside it? So can you see over here the values are given? So what is written over here for values?
It's like range of like
A
starting
range
to
9. So np dot a range 9. If you remember from NumPy, np meaning NumPy dot a range. So a range 9 will what will it make? Range
0
till
to
9, right?
till
So what will be the values?
0, 1, 2, 3, 4, 5, 6, 7, 8.
So it simply means that 0, 1, 2, 3, 4, 5, 6, 7, 8 until 9, right? And it is saying that take this 9 values and reshape into 3 cross 3. So make it at 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So it has first said that take this value 1, 2, 0 to 8. That is a range of 9. Then shape it into 3 cross 3, something like this. So this will be 0, 1, 2, 3, 4, 5, 6, 7, and 8, right? 6, 7, and 8. So you got it this. Perfect. So that's perfect. This is my first data frame. Similarly, can you explain me what will be my second data frame look like? What is my second data frame going to look like?
Yeah, it's
What is the name of the data
cross,
frame?
name DF2.
DF2. What is the range we are taking over here?
0 to 12,
0 to 11.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, until 11, right? Perfect. What is the shape of it? It is asking to shape into what?
3 cross 4.
3 cross 4, right? So it will be 3 like this and 1, 4, right? So if I look into this part, this particular part is 3 cross 4, 3 cross 4. So if I want to put this 3 cross 4 over here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? What is the name of the rows and columns? What is the rows?
Some R1, R2, R3.
Rows is R1, R2, R3. Rows or index is R1, R2, R3. What is the name of columns?
A, B, C, D.
A, B, C, D. Okay. So you should be able to read the code and out of that visualize what should be the output. This is the level you have to reach. So we are getting this data frame 1 and data frame 2. If I add this data frame 1 and data frame 2, what will happen? What will be the output if I add these two data frames? What will be the output?
So it
This
will
plus
add,
this.
yeah, each index
Adding to
element.
matrix.
So there will be A, B, C, D, R1, R2, R3. What will be the output?
0, 0, 2,
This 0 plus 0?
0,
0. This 1 plus this 1?
2,
2 plus 2?
4,
Null plus D?
null,
Null plus 3?
null,
Null. Right? 3 plus 4?
7,
Then
9, 11, null,
then
14, 16, 18, null.
okay. So are you able to interpret? We saw in the series also, if you want to add something with a null, the output should be null, and it should take the hereditary here as well, right? So this is what we have interpreted from looking into the code. And if you are able to interpret it, you are in the good shape. So if I run this thing, so 0 to 4, NaN, 7, 9, 11, NaN, 14, 16, 18, NaN. This is what we discussed. Any questions over here, anyone? Any questions, anyone? No questions, let's go ahead. df1 dot add df2 fill value 0. So can you guess what will be the output of this? It's same thing, df1 plus df2, right? Over here also we are doing df1 plus df2, but we are saying that fill value 0. So what will be the output?
I think for null values, it will replace the null with 0 and then it will add.
Right. So as you guess rightly, right? So since over here the D column was not there, since the D column was not there in the first data frame, it was resulting as NaN. But since the D column is not there in the first data frame, it's just replacing it with the fill value as 0. And it's adding 0 plus 3 as 3, 7, and 11, so that the output is not getting 0. So you have a fill value, right? Okay. Any doubts in
So
this?
Harish, basically this fill value will be like applicable to both the data frames when we are doing this syntax, or it will be applicable only for DF1?
It will applicable for both.
So basically, if any of this data frame will have a null value, it will replace with zeros.
Yes, you can do it like this. You want to check, you do it df2 over here, df2 over here, df1 over here. You do df1 over here, and vice versa. Then it should still work.
Okay.
So any of the data frame has a null value, it will just replace it with 0. All these things depends on the person who has implemented it, but it's ideally just that, okay, the person should have implemented it properly. If you look into some other package, it may work differently as well. So it depends on who has implemented this add function inside Pandas data frame. So, okay, how to see this add function, how someone has implemented? Since you discussed, right? How do I see? Then you go into Google. Then write GitHub for what is this Pandas? GitHub for Pandas. So GitHub Pandas. This is a source code. So powerful Python data analyst. So good. So it is an open source, right? The latest version is 1.3.2. So you can see the release notes by clicking here. If I want to see how is the add function implemented, def add, and in this repository, so def add, that's not def. Maybe def add open bracket. There are so many adds. So def add, still not able to find it. Def add, right? This is a test number.py. Doesn't look like actual code. Def add something else. Should take a data frame for adding. Why? Maybe it is showing some limited result, right? Showing the top 3 matches. So unfortunately, this only shows the showing the top 4 matches. Is there having multiple add methods, right? If I do this, can I see?
Harish, these are the kind of official libraries which comes with the package. So, or is it some random person made these libraries and that's why we are finding it in GitHub?
No, we are not. We are looking onto only into pandas, right?
So there is no official source like because these are the most used libraries like
This is the
NumPy
official
and
source only. This is the official source only. If you go to pandas.pydata.org, and your Google is going to give you the good result only on the top. So this is the pandas.pydata.org is the official website. And if you go
so
into
then
contribute, it is going to take you to uh,
since it's open source, so it will have the code of all these things over this site as well, right?
Yes, it will have.
You can search in here where is the definition of add function in pandas and all.
Yes. So pandas.dataframe.add is what we are doing, right? Pandas.dataframe.add. So if it's easier to look from here, so from the documentation, you can also go into a code later on to see pandas.dataframe.add. So this is the fill value that we were looking, and float or none. So this is over here, and pandas.add, dataframe.add. So it is referring to here only. He's saying that you can also see add, subtract, multiply, divide, true divide, floor divide, mod, and power. And he has given some examples. They've given some examples over here. There should be good number of examples. I mean, if you want to see anything in more detail, you can come and see over here for the examples. And you should be able to see the source code by clicking over here. So this is the source code, right? So if you click on source, so it is over here. I cannot see add. So add. Should be something like this, right? Should be the function definition should be like this. It's a flex arithmetic method frame, OP. How have they implemented it? Should reindex def f. So it is implemented as def f, right? So what they have done is this f will probably have a different values, and fill value is over here. So this f over here can be add, multiply, subtract, and divide, right? Whatever. So that's why we are not able to find directly with the name add. So this is a self, that is the one that you are invoking with the df1. The other with whom you want to add it, df1 and df2. Then access value is a default access, that is you want to add it each row wise. Level is none, fill value is none, right? So these are the different parameters that it accepts. It's not defined as add, it's defined as f. And yeah, of course, I mean, before going to here, should not reach over here, at least for now, unless you want to contribute to this Pandas project. And it's among the flexible wrappers. So add, subtract, multiply, divide, POW. It is also working for these operators. So instead of add, you can also use plus operator, subtract, minus operator. So I mean, this should be the best point you can reach to before going into a GitHub. Okay, so coming back to where we were, so it will give you more details about it. Of course, if you want to see more, you can also do df1 dot add question mark, right? And df1 dot question mark. So it gives what it is doing. These are the different things and what all. You can just read about it, and all those examples from the documentation you can also see over here. Okay, so this should be a first point of help. In fact, before going to that also, you can just do a question mark. See. Okay. So coming back to where we were. So can you tell me what is this doing? How many rows, how many columns? What is the value?
3 rows, 3 columns from 0
3
to
rows,
8.
3 columns, 0 to 8, right? 0 to 8, 3 rows, 3 columns. The name of the rows is R1, R2, R3. The name of the columns is ABC. So the print df3 will be what you said. This one, right? Then what you are doing over here is you are saying that I want to make a series. I want to make a series out of this data frame 3 and I log 0. What do you mean by LOC and ILOC? What is LOC and what is ILOC?
ILOC will refer to the index, actual internal index, and LOC will refer to the index we have specified.
Okay, LOC will refer to R1, R2, R3. ILOC will refer to 0, 1, 2, 3, 4. So if you do ILOC 0, meaning if for this particular data frame, which one will be selected? ILOC 0?
R1.
R1.
R1, right? So this is my 0. Okay, because this is R1, which is 0. This is 1. This is 2. So if I say df3, dot ilog 0, meaning this one R1 will be selected. It will come into a series, and then you can always print this series, so you get this 0, 1, 2. Is this clear? Any doubts in this?
Can we do 0, 1 or something like that also to refer to a particular element?
So you're saying that comma 1, like this, is it?
Yeah, so it will refer to 1.
So 0, 1 meaning it is referring to 0th over here and first over here.
Yeah.
We are going to do this anyhow later on, yes. So when I say only 0, then it refers to this one, and it has created a series for you. It has created a series for you. Now the series is having an index ABC. Series is having an index ABC. Just take note that when it took 0, 1, 2, 0, 1, 2, for the series, the index is ABC. The index is A, B, and C. Okay. So what will this DF3 plus series do? What will be the output? Can you say without looking this? What will be the output over here?
It will like add each element with this series, like A to
Sorry?
like A to A, B to B, C to C, like that it will add.
It will add
For
A
each
to
row.
A, right? So this
Yes.
0 plus 0 is equal to 0. This 1 plus this B1 is equal to 2. This 2 will be added with the C2 will be equal to 4.
Same way for next.
Yeah. So similarly, this 3 will be added to 0, 3. 4 will be added to 1, 4. 4 will be added to 1, this 5. 5 will be added to 2 will be 7. 6 added to 0, 6. 7 added to 1, 8. And 8 added to 2, 10. So this is how you add a data frame and a series. Okay, let's go ahead and let's discuss this one. This one, what is this doing? What will this do? What will this do?
It will create one 3x3.
A data frame name
data
is
frame.
DF4.
Yes.
A range 9 means 0 to 8. So 0 to 8. Arrange it in a shape 3 cross 3. So 3 rows and 3 columns. Arrange in a rows 3 cross 3. So 3 rows and 3 columns. Index is R1, R2, and R3. Index is R1, R2, and R3. Column is A, B, and C. So this is what you get, right? So this is your data frame 4. Now DF4B. So what I have done over here is I have specified the column that you are referring B. Specified the column that you are referring B. So it gets 1, 4, and 7. 1, 4, and 7. And what do we do over here? We just keep on adding this 1, 4, and 7 to each and every element. So 0 plus 1 is equal to 1. 3 plus 4 is equal to 7. 6 plus 7 is equal to 13. 1 plus 1 is equal to 2. 4 plus 4 is equal to 8. 7 plus 7 is equal to 14. And 2, 5, and 8 added with 1, 4, and 7, you will get 3, 9, and 50. Okay. So this is how we extracted a particular column out of it. So if you want to extract column, we extracted it with just a bracket out of it. Okay. Any doubts so far? Okay, if I want to get R2, how will I do? If I want to add R2, then okay, in this example, we took this one R1, right? In this example, by specifying 0. If I want to specify R1, then how do I do? I don't want to specify the internal index. I want to specify R1.
We'll say I'll lock R1.
LOC of R1.
LOC of R1. Okay, so LOC of R1. Either you can do LOC of R1 or you can do ILOC of 0. Okay, so let me write over here at the end You can also do LOC of R1 df3 dot, right, instead of df3 dot ILOC. Okay, perfect. So what you said was you can also do LOC of R1, right? LOC of R1. You can also do a LOC of R1, or if you want, you can also do a ILOC of 0, one and the same. ILOC of 0 is one and the same. Okay, so LOC of R1 is working fine, right? LOC of R1 is working fine. Can I remove this LOC? Can I remove this LOC?
Yes.
Okay, but it failed. Why? Why it failed?
Maybe it is not supporting LOC without LOC.
It is supported without LOC also.
When it is two-dimensional, I mean, basically two-dimensional meaning, yeah, we need to give R1 dot
No,
A, comma A.
no. Because when you are using without LOC, in case of data frame, it tries to find the column. It tries to find the column. Okay, it tries to find the column. So if you are doing without LOC, R1 is your row, R1 is your index, so it won't work. Okay, so you cannot do this way. Okay, so what note I wrote, you can also do as this, but you cannot do as this. Okay, you cannot do this, but you cannot do as this. This was only possible in series. It was only possible in series. In case of data frame, it will try to look for column R1 that does not exist. Okay, so this is the some things that you will have to remember for some time. ILOC. Okay, so you cannot just refer to this one, because if I write just like this, it is trying to look into the columns, right? So always remember, before we end today's session, always remember, if you want to refer to this kind of a index, if you want to refer to an index in a data frame, either use LOC or use ILOC. Okay, if you want to refer to the index, use LOC or use ILOC. If you want to refer to the columns, then use directly, data frame followed by directly. But if you want to use it, use this way. But in case of a series, you could also refer, this was also part as a of an index, right? Because in series you were not having multiple columns, so the same syntax was working like this, right? So always remember, I mean, so that's why I said for index, in when we were discussing for series also, always use LOC and ILOC. Don't go for this syntax. Okay, because this syntax in case of a data frame will refer to the columns. So there is a very important thing to remember. For indexes, use LOC or ILOC. For the columns, use directly the bracket name. Okay, any questions in this so far? So hope my screen is still visible, right? For referring to rows or index, one and the same thing, use LOC or ILOC. Okay, this is my node. Use LOC or ILOC. For referring to columns, use df bracket name column. Any questions, anyone? Okay, if no questions, then we are good for the day. We'll continue tomorrow, same time. Thank you.
Harish, for columns, we can even use LOC also, right?
For columns, you cannot use LOC. Columns will refer to rows. Rows. Columns. I mean, LOC is only for rows
Okay.
or index. LOC and ILOC. Column name directly specify in bracket. We'll do more tomorrow. Yeah. But yes, LOC is only for rows.
Okay, Harish.
Harish, actually, I have some query from the last assignment of NumPy.
Okay.
So